in our livestock-based food productions, an important element is how those animals take those components, those plant-based components, and convert them into products that we find palatable and digestible.
Taking care of nutritional feeding is so important because it comprises such a significant proportion of the costs of our production. And that's true for all of our systems. But the actual proportion varies depending on the species and depending on the type of system under consideration. How much nutrition contributes and how much it costs depends on those things. Dairy cattle, for instance, that are raised somewhat on pasture, nutrition might be 50 to 60% of those costs, whereas with pigs it might be 80% of the cost of production in a swine system. But because of these costs, optimizing the nutritional content and matching it with the production outcomes is an essential part of the management of running of an efficient, effective, and profitable system.
Because the costs are such a high proportion of the total costs that go into an animal. And nutrition, feeding an animal, isn't just simply turning them out onto a pasture or putting feed in front of them. Nutrition is a complex scientific process. Feeding the animals exactly the right constituents at exactly the right time is really important for the sustainability of production. And to understand nutrition, to be able to design good nutritional programs, you need to be able to understand not just the components of the nutrition, not just what the components of plants are and how they're made up, but also the anatomy and physiology of the animal, how their intestinal tract works, how they digest nutrients, how they maximize those to become most efficient in production. So I'm Dr. Brian Aldridge. I'm here at the College of Veterinary Medicine at the University of Illinois, and we're in the Department of Anatomy. And to start to understand that science of how nutrition works, we're going to go inside of a cow. This is a skeleton of an adult cow that's used here as an anatomy demonstration to teach the veterinary students the structures that are inherent to the function of this animal. And we want to just show you where the major part of the digestive system sits. For ruminants, they're unique because they have 4 compartments to their stomach. And within their abdomen, they have a massive fermentation vat called the rumen. That's the second of the stomachs. And it sits right here within the belly of the animal. And all of the other structures are secondary to really this rumen in the digestive process. The rumen lining has small little papillae, little leaves, tiny little microscopic leaves, which increase the surface area of the rumen and therefore optimize its absorptive capacity, absorbing the breakdown products of the bacterial fermentation, particularly the breakdown products of carbohydrate metabolism, the volatile fatty acids. And that is the seat of efficiency for nutrition and the seat of efficiency for production as far as nutrition is concerned. So here I am holding the 4 stomachs of a ruminant inside the abdomen of this cow. So that's exactly where it sits. But if you think this is the real structure and this is the real size, I'm fooling you because this is actually a sheep's stomach. And it's about 1/10 of the size of that which would sit inside this cow's abdomen. Now this is the real rumen of this animal. And as you can see, it's massive. It's a massive fermentation vat. Probably altogether, this structure holds something like 300 liters. 300 liters of fluid. Each compartment structurally designed both in its form and its function to most efficiently take undigestible proteins and carbohydrates and make them digestible. Firstly for the animal, and then to convert them into metabolic products. So let me talk you around the different stomachs in this specimen. The ruminant is unique in that it has 4 stomachs. This here is the first stomach. It's called the reticulum. The reticulum is, in some ways, the first compartment that the food meets. The food comes down the esophagus, down the throat, and through a small sphincter here, and is then dumped into this part of the stomach. It's lined with a reticulated mucosa, which is designed to capture particles. And it's so effective that if the animal swallows a piece of wire, to prevent the wire from accessing lower parts of the intestine, they get trapped there. Stones will get trapped in this honeycomb appearance, stopping its interference with other digestive processes. And every part of this remarkable stomach system is unique in structure, but also in lining, and also in its contents. Each of them, though contiguous, perform a different function because of their anatomical structure. But this is also the part of the stomach, when the food is chewed again and again, this is the food that goes back up into the mouth.
So a ruminant doesn't just chew its food once. It takes in the food, it goes down into the reticular rumen, and then it's brought back up and down so that this plant material is, in a stepwise fashion, crushed and broken up. Now this occurs by a repeated process of chewing, of swallowing, of entry into the rumen vat, and then of bringing it back up.
So this is where rumination takes place. This is also the first sac of this fermentation vat, and food moves from this structure into this large multi-sacked part of the stomach called the rumen. This is where all the fermentation takes place. Again, it has a unique structure of sacs because that's where most of the mixing takes place. It is mixed up so that the bacteria are exposed to every part of that digester. And there's 3 layers of food in this rumen. There's the top layer, which is the gas, which is a byproduct of digestion. There's a fiber layer that sits in there, and that's the part of the fiber that goes into the reticulum and is re-chewed. It's the long fiber. And then at the bottom, there's food particles suspended in liquid. It looks more like pea soup. And that's where the bacteria are doing most of their work, being exposed to the small fibers and doing the digestion, taking the plant proteins and the complex carbohydrates and breaking them down into simpler proteins and simpler sugars as well. Probably about 1.5 billion bacteria live in that in the animal. From there, as the food is broken down, the more liquid component goes through another sphincter, another opening into this omasum. And every stage of digestion, the particles are going from long fibers to smaller fibers. And when it gets to there, it's essentially smaller particles with a large amount of fluid. But to get down into the smaller parts of the intestine, in the lower parts of the intestinal tract, most of the water should be removed, and that's what takes place in this omasum. The lining of the omasum is like book leaves, and it's a perfect way to increase the surface area so that water absorption could be maximized. And that's where a lot of the water is absorbed. From there, the food goes into what is really the true stomach, the abomasum. The stomach that in humans and in pigs and in horses does most of the digestive processes of the gastric part of the intestine. It's the true stomach because that's where some of the enzymes are produced that digest some of the carbohydrates and the proteins. The lining of the abomasum is glandular. It's full of folds, but it's secretory, the only part of these 4 stomachs that secrete anything. It secretes the digestive enzymes. It secretes the hydrochloric acid to lower the pH. It's a true stomach because its acidity, its pH, is much lower than the rest of the intestinal tract. The secretion that comes out of the lining of this is hydrochloric acid, as with humans and as with other monogastrics. So the components of this part of the digestive tract have been simplified from the long fiber that we've seen in the rumen. And the bacteria in the rumen have done most of the digestion. They've been breaking down the celluloses and the starches to more simple sugars. They've been taking the protein in those plants and breaking them down to their essential acids. In fact, the bacteria then take the amino acids and put them into the protein of their own body wall. And they form part of the nutrients for the lower digestive tract. The abomasum's role and the lower intestine is to take those bacteria and break them down and to release the nutrients that they have released from the grasses and the grains that took place during the fermentation process. So in some way, for the ruminant, the bacteria become an important dietary component. The bacteria break down the plants, and then the rest of the body digests the bacteria. But there's things that we do nutritionally and managementally which affect the structure and function and contents of these rumen. If we don't get the nutrition right, then we mess up the function of this wonderful organ, and therefore we decrease productivity.